The Nintendo Entertainment System, or NES, has its own characteristic sound. It's 8-bit, but it's distinct from other 8-bit systems of the time. You can usually hear whether a chiptune is NES or not. And there are two significant reasons for that. The first ingredient is the fixed channel structure. The NES has 5 sound channels, meaning that you can play 5 sounds at the same time. But the channels are different and each one is limited to a specific type of sound. So you've got 2 channels that can only play pulse waves, one that only plays triangle waves, one various kinds of noise, and the final channel is a lo-fi sample player, mainly suitable for drums and sound effects. So writing music for the NES is like composing for that particular quintet of instruments. The second earmark of the NES sound is the triangle waveform itself. Now, a normal triangle wave sounds and looks like this. But the NES approximates a triangle wave like this, which is better described as a staircase with 16 steps and a fair amount of overshoot. It has a unique timbre, rich in overtones and quite different from the built-in waveforms of other contemporary sound chips. Presumably the engineers who designed the NES regarded this as a compromise. They sacrificed some sound quality in order to minimize chip area and keep the cost down. But now, for a generation of kids who grew up with the NES, this sound invokes a warm, fuzzy feeling of nostalgia and can be appreciated as desirable or even beautiful. It deserves to be turned into an instrument. Now, it's perfectly possible to emulate this peculiar waveform on a modern computer or synthesizer. But why emulate when you can have the real thing? So I spent some of my Patreon money on this, a sort of development cartridge for the NES. And I read through the excellent technical documentation at nesdev.org, and now I can build a ROM image, put the image on an SD card, put the SD card into the cartridge in the console, power on, press start, and look, it's running my code. This here is an early version, my very first attempt at an NES-based instrument. It's played with a standard hand controller, and you use the direction pad to select a note from one of these circles. You can switch circles with select. And then you press B or A to play the highlighted note in a low or high octave. It works, but it turns out to be ill-suited for rapid bass lines, and it's also putting a lot of strain on the left thumb. So I started looking around for alternative NES controllers, and I discovered this. And once again, with the help of my supporters on Patreon and Steady, I was able to get my hands on one. This is a Family Basic keyboard. As many of you already know, the Japanese version of the NES is called the Family Computer, or Famicom for short. It is for the most part identical to the NES on the inside, but different on the outside. The Family Basic cartridge turns the Famicom game console into a programmable home computer. Along with the cartridge, you also got a textbook and this 72-key QWERTY keyboard. And as you know from my earlier videos, I've developed a way to play a QWERTY keyboard like a chromatic button accordion. There's just one problem. I wanted to use my NES for this, but the Family Basic keyboard plugs into the expansion port of the Famicom. The NES, being essentially the same console, also has an expansion port with all the necessary signals. It's located at the bottom, behind this curious cover, but also behind this breakaway tab. And I didn't want to break away the tab. Besides, the connector behind it is a bit different, and I would have had to buy or build an adapter. And in that case, why not build an adapter of my own design for plugging the keyboard into one of the controller ports on the front? But that's not straightforward, because there are more signals coming from the keyboard than there are input pins in the controller port. So I ended up using a microcontroller, an AT-Tiny85, to take 4 digital signals from the keyboard and combine them into a single serial bit stream that's transmitted over and over to the NES, where I can decode it in software. Then there's a signal from the NES to the keyboard, telling it to advance to the next 4 bits, then the next 4, and so on. In this way I can scan all the 72 keys in one continuous loop, but there's a snag. There's also a limited number of wires going from the NES to the keyboard, and I had to leave out the reset signal that tells the keyboard to start transmitting from the first key. So I'm receiving this endless data stream from the keyboard, and I know it's cycling through the keys in a specific order, but I don't know where the cycle begins. I solved this problem in a sneaky way. When the program starts, it says press space to begin, but it's actually waiting for any key to be pressed, and when it happens, it knows that that key must have been space, and so it knows the position of every other key relative to that. So now I can play the NES triangle wave using the Family Basic keyboard. And I call the resulting instrument the Family Bass. And if you want to hear it in a song, head over to my video called Platform Hopping with the Family Bass. See you there!